right, so we're back talking about geometry. We're on section 8.3, the geometry section. We do two sections in this book, 8.3 and 8.4. I'm going through some of your sample homework problems. So I'm up to number 12, and we're talking about the circle. We're talking about the circle formula. We're finding its area and its circumference on this. The example I have is a circle that has a diameter all the way across is a diameter. And in my example, this says 25 feet, a 25-foot diameter. So the thing about the circle is we use this pi value, and just to remind you, pi is so important that it's usually on every calculator, so I expect your calculator has a pi button. And I notice in your homework you need to use the pure pi button without round-off error. A lot of times we call pi 3.14, but that is our abbreviation, a rounded amount. Actually, if you look here, you can see pi, if you hit the button, is 3.141592654, and then it keeps going and going. It actually is an irrational number. It never stops. It never has a repeating pattern. It can never be expressed as a pure fraction value. It has no equivalent fraction value. So to get exactly the right answer, you want to use the pure pi value, pure pi button, or use 5 or 6 of these digits anyway in your calculations. All right, so on A part, to do the area is pi r squared. You might hear that. Pi r squared is the area of a circle. So pi button, and then times, since it says radius squared, 25's all the way through, we'll need to half that. So the radius would be half of 25. But daggone it, it's an odd number, so I can't half it, as easy, but it will be, 12.5? If you want to see it as a decimal, you could do that, or you could say 25 over 2, either way. This one comes out, it divides pretty nicely, so if you want to call it the decimal form, 12.5, perfectly equivalent. But you'll do that on your calculator, pi times that radius squared. Check your calculation. We are squaring the radius, so the radius is in feet, so when you square feet, that's why the area comes out in square feet. And the area of things is how much is inside of a figure, so the area is in square units. For circumference, that's how far around a linear amount, like if you were wrapping a belt around something or a piece of yarn, it's linear units, so it's just in regular feet. But it's pi times the diameter. Pi times d is the circumference, or the distance around a circle. So the diameter is 25, given in my problem. Yours will regenerate differently, but pi times 25 gives us 78.54 in regular feet. Rounded to that. I rounded to hundreds. I'm not sure. Maybe your directions will tell you which place to round to there. I did 2 places. All right, number 13. Now we'll move on to the next formula. Moving out of the circle. The next thing we're going to talk about is the Pythagorean Theorem. It's another real popular or common, important algebra, not algebra, but I'm going to say geometry, a subset of it, geometry concept. So try to get this board to clean up for us. We got a powerful marker in this time. All right, so Pythagorean Theorem. Let's see if I can still spell this. Okay, I think I got it. Pythagorean Theorem. It has to do with right triangles only. It only applies to a right triangle, so it has to have one right angle in it. And then what the Pythagorean Theorem says is the two sides, the shorter sides, this squared plus that squared, and it doesn't matter in what order, but these two sides squared added together equals the hypotenuse. We call this the hypotenuse. The longest side, distance between these 2 points, is the hypotenuse. It's always across from the right angle, so the hypotenuse squared. So we can call these A or B, doesn't matter which one, but the hypotenuse is always labeled C. And the formula says A squared plus B squared always equals hypotenuse squared. And again, these are reversible. It doesn't matter which one you write down first, but that does matter. The formula, these two added together, squared and added, always equals the hypotenuse, stands alone, equals the hypotenuse squared. All right, so we've got some practice problems to do with this. So if you'll notice, I'm on number 13 of your homework set. Okay, we have an example with right triangles kind of turned this way, that no matter. We've got 28 yards here in my example and 21 yards here. It says figure out what the hypotenuse must be. So this fits perfectly. These are the sides. It doesn't matter which one you write first, but 21 squared plus 28 squared will equal unknown. We'll call that c squared. So type that on your calculator. That is this squared plus that squared comes to 1225. Check your calculation. Now notice that is c squared, so to get this completed, we will need to square root. To undo squaring, square root takes care of that and gets c alone. We've not had to do that in any of our previous examples, I don't think, this semester. But to get rid of c squared, it takes a square root, because square root and square are opposite operations, and will bring out regular c. So when you square root, so find your square root button of 1225, you should get to a final answer of 35, and that is in yards. So this hypotenuse should be 35 yards. Well, then that allows us to answer some other questions. Now we could answer the perimeter, distance around, and we could do the area. So the next question is, what is the perimeter of this triangle? Perimeter means distance around, so it's 28 yards plus 21 yards plus 35 yards. I don't know how I drew that. Plus 35 yards, all just regular. They're all in like units, yards. So we add that together, and let's see, 14 carry the 1, 4, 5. Is that 84? 84, and it's in yards. Since it's distance around, it's in the linear unit, 84 yards. The next question we could do is, what is the area? What is the area inside of this figure? The area inside will be in square yards, and that's one we haven't talked about yet in this section, the area of a triangle. So what is the area of a triangle? Well, earlier we did the area of rectangles and four-sided figures, and that was base times height, right? If you have a full rectangle or parallelogram four-sided figures, we learned that the area is the base times the height. Well, a triangle, if you split that in half, you'd have two of those inside of any four-sided figure. So we say that a triangle is just half of that. That should be an H, base times height. So the area of any triangle is 1/2 base times height. It's half as big as would have been the four-sided figure. You fit two triangles into any four-sided figure. So the area is half base times height. Keep wanting to make that H into a V, don't I? All right, so for our example, 1/2, the base is what the perpendicular line lands on, which will be just straight up and down what it lands on here. That's your base, 21 yards. And then your height is that perpendicular distance down. We talked about a plumb line hitting the floor. This is the floor, the base. And then that is your height, the height from the ceiling, 28. And those are both in yards, so when we multiply, it will be square yards. So type that away on your calculator, and you should get 294. And again, it's square yards because it's in area. 14 is pretty much a repeat of that, so if you want to pause the video at any time. I keep forgetting you don't have these exact problems in your handout. I just gave you formulas. So I need to quit saying that, right? I need to quit telling you to look at your handout. I'm going to have to give you that problem. Well, anyway, we are going to do another problem just like this one to practice it again. So let me write it on the board, and then you can pause the video to practice. If I can get the board erased. All right. So the next example I have for you looks like, where did it go? Looks like this. We have a right triangle, and we have a side that's 12 kilometers, and the hypotenuse is 37 kilometers, and then we don't know what this side is. So if you want to pause now and figure out what this side is, also figure out the perimeter and figure out the area is what we're going to do in this. So first of all, to figure out what B is, we use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So we'll say a side, the side, and this is a side, and of course across from the right angle, that has to be c, so it doesn't matter which one of these you call which. So I'll say 12 squared plus unknown squared equals c squared, which is 37 squared. So square those on your calculator. You will have 144 plus b squared, and 37 squared is 1369. Now we'll have to do a little algebra on this one, equation solving, To get the 144 over to the other side, I'm going to bring that over, so minus 144. And then we'll have b squared equals 1369 minus 144. I think I wrote that down somewhere, 1225. Then to get b alone, because it's b squared equals, we need to square root as our last step. So square root both sides, that cancels that out, leaving the b equals. Square root of 1225, do that on your calculator, and you should have 35, and these are all in kilometers this time. The unit we're using is kilometers. So now we know this side is 35. Now we can answer the area and the perimeter question. So next I'll do the perimeter. Perimeter is the distance around the figure. So it's just adding the three sides. So 12 kilometers plus 37 kilometers plus 35 kilometers. And it'll be in just regular kilometers, linear units, so it's 84 kilometers. Next, we'll do the area. The area of a triangle is 1/2 base times height. Now we know the base, this base, the floor of it is 35 kilometers. And the height, this perpendicular distance, is 12 kilometers. So we'll type that away in your calculator as well. You get 210, and is kilometers times kilometers, or square kilometers for the unit for area. All right, I've got one more example similar to that. So to practice the Pythagorean Theorem one more time, and a couple other things. Getting through. Still having trouble with this board. I like the marker, you can at least see it, but it doesn't want to erase very well, so I apologize for using up your time with my erasing work. Maybe I should switch markers, you're thinking. I like this bright marker, so I'm going to try to stick with my pattern here. All right, next example, I have a right triangle. Sometimes they turn them left, right, upside down, so no matter to that. I've got 48 inches, and then I know the hypotenuse is 50 inches. Then I'm asked to figure out that side and then do the perimeter and the area questions. So to figure out the side of a right triangle, that's the Pythagorean Theorem, a squared plus b squared equals c squared. What's important to note is c is always across from the right angle, so 50 is c. And it doesn't matter which one of these you call a or b. So I'll just call A, or I guess they've kind of called it there, but it doesn't matter though. We'll say we don't know A, and then we know B is 48. So that's how we put it in our formula. Then square 48 and 50 on your calculator. I've got that listed as 2304 and 2500. Equation solve that by moving that across the line. So A squared equals 196. Then we can square root to finish solving, and the square root of 196 is 14, and it should be in inches. So A is 14 inches from our Pythagorean Theorem. Then we can do our perimeter question. The perimeter is the distance around, so 50 inches plus 48 inches plus 14 inches, and it'll just be in regular inches, which is 112. That's your perimeter. Then we can also know the area. Area of a triangle is 1/2 base times height. So we know the base now, we know that is 14 inches. And we know the height, the perpendicular distance down is 48. So type that on your calculator, 1/2 times 14 times 48, and it will be the base is in inches, the height is in inches, so that multiplies to be inches squared. And it's 336 inches squared, or square inches for that. All right, I have a few more problems I want to do with you, so I'm going to have to pause, though. You all know I can only do 15-minute YouTube videos, and that's my limit. And maybe that's all you want to listen at one spell, so a lot of times I'll abruptly stop and have to come back in on the next one, so I had a couple minutes to say that, but not enough time to do the rest of my examples, so I'll see you in just a minute.